Hi, this is Foundations of Math and Pre-Calculus 10, Chapter 4.4. We're going to look at irrational numbers. But first, you need to recall that a rational number is a fraction with integer numerators and denominators. So an irrational is when a number cannot be expressed as a fraction. Recall that fractions have repeating decimals. So, for example, we have 1 over 3, 0.33333, 1 over 7, it's long, but 142,857, 142,857. And a half, well, it terminates. It's actually just 0.5, but we can add zeros to create the repeating pattern. Now, if we take a look at square root 2, I grabbed this off the internet, I would say that it was very hard to see a pattern in here. And one could argue that there is no pattern. Okay, you have to take a block and repeat that block. Here's a proof of irrationals. If square root 2 were rational, then we would have square root 2 equals p over q, right? It needs to be expressed as a fraction, such that p and q are reduced. So, we're going to do algebra. We square both sides. As long as we do the same thing to both sides, we haven't changed the equation. Square root 2 squared is 2, and then we have p squared and q squared. We bring the q squared over to this side, so we multiply both sides by q squared. So we have 2q squared equals p squared. Now, p must be even because we have a 2 here. And note that it's p squared, so we can't just have one p that's even and one p that's odd. They both must be even. Now, if p is even, then we could say that p is equal to 2r. So let's substitute 2r in for p. So now 2q squared equals 4r squared. We divide both sides by 2. And look, q must be even because of the 2 here. And if p and q are both even, this contradicts our assertion that p and q are reduced. So, therefore, square root 2 is not rational. Anytime we have a radicand that is not a perfect square cube, then it's irrational. Now, just so that we are clear on what I'm talking about, let's just write this down. N root x. This is called a radical. This is called the radicand. And this is called the index. Okay, so question is square root 0.64 an irrational? Well, 0.64 can be rewritten as 64 over 100. And we can take the square root of 64 and we can take the square root of 100. That's 8 over 10, and it reduces to 4 over 5. So this is rational. Now, a handy thing to remember is this. So we can convert between radicals and rational exponents. So convert this to a power. M goes on top. So this is 4, 5 over 3. Convert this to a radical. Okay, so we're going the other way. So the 2 goes to the inside. So we have the third root of 9 squared. We could simplify this one step further if you want. So this is 3 squared squared. So this is the cube root of 3 to the power of 4. Okay, another way to express radicals is mixed radicals. And what we do is we factor out all perfect squares, cubes, or whatever the index is. And the other one is entire radicals, where we bring any coefficients inside the radicand. So this is how we do it. This is square root 9 times 5. 9 is a perfect square, so we have 3 root 5. Cube root. Okay, so we tried to do some factorization. This is 27 times 2. So we're taking the cube root of 27 and the cube root of 2. And 27 is a perfect cube, so we have 3 cube root of 2. 28, that breaks down to 4 times 7. And 4 is a perfect square, so we can pull that out as 2 root 7. Now let's go the other way. We need to bring 4 inside. The index is implied to be 2. We need to square 4. So that's 16 times 3, and this is square root 48. The index is 3, so we need to cube 2. So this is the cube root of 2 cubed times 5. And the cube of 2 is 8 times 5. So we have the cube root of 40. Again, the index is implied to be 2, so we need to square 7. Square root 7 squared times 3. And that's 49 times 3. If we made this 50, we can do the math in our heads. So 50 times 3 is 150, but we need to subtract 3 because it's 49. So this is 147. And another task we need to do is to be able to order radicals. And we need to convert them all to entire radicals using the same index. And the other option is just to convert them all to decimals. Okay, these are all square roots, so that makes it easy. So we have square root, 4 times 4 is 16. 3 squared is 9, times 2 is 18. 2 squared is 4, times 7 is 28. 4 squared is 16 times 3 is square root 48. And we just leave that alone. There's nothing to do because that's already an entire radical. And to order this, we simply need to move this one to the front. So writing our final order, we have root 10, and write out the original radicals. This is 2 root 4, 3 root 2, 2 root 7, and 4 root 3. And that completes this lesson.